Hello everyone, my name is Harishankar Shah and in this video I will explain my project titled AI based environmental pollution monitoring using machine learning. The main goal of this project is to analyze large scale environmental pollution data and apply machine learning techniques to predict air quality indexes value and classify air quality level based on historical pollution data. This project combines data science, machine learning, and real world environmental monitoring, making it both technically strong and socially relevant. Air pollution is a major global issue that directly affects public health, climate, and quality of life. Traditionally, pollution monitoring systems mainly focus on reporting current pollution level, but they lack predictive intelligence. So the problem I address, how can we use historical pollution data and machine learning model to accurate predict air quality and categorize pollution risk level. Machine learning is suited for this problem because pollution are nonlinear, influenced by multiple pollutants, time dependence, and this motivates the use of supervised learning models, especially on a symbol method. Now let me demonstrate the AQI prediction system. This system is built using Python Flask as a backend and use a random forest machine learning model for prediction. First, I enter air quality data, nitrogen dioxide as 20.1 part per billion and ozone 0.045 part per million, sulfur dioxide 5.2 and carbon monoxide 0.25 and year 2026 and month August. Then I click on the predict AQI button. The system predict AQI value is 38.17 and classify the air quality as good. This demonstrates how the system can quickly analyze pollution data and provide real-time air quality insights using AI. Now, let me explain each of the code how the system works. For this project, I used the US pollution dataset from Kaggle, originally sourced from the United States Environment Protection Agency (EPA). There are time period 2000 to 2016. Total row 1.6 million. Total feature 29 columns, and the major pollutants analyzed on nitrogen dioxide, ozone, sulfur dioxide, carbon dioxide. Each pollutant include statics measurements such as mean concentration and AQI value. This large-scale real-world dataset which makes the result reliable and realistic. Before modeling, I perform extensive pre-processing and exploratory data analysis. Key step including feature engineering, extract year and month from the date, and the final date range is 2000 to 2016, and month range is 1 to 12. Uh, then we select the feature where we use the feature nitrogen dioxide, ozone, sulfur dioxide, and carbon monoxide, and the final target value is nitrogen dioxide AQI. After that, we remove the missing value and check for remaining missing value, and then display the basic statics of the clean data where we can see the nitrogen dioxide mean and o- and uh, ozone mean and overall. Now we can see data visualization. There are basic data analysis, distribution of pollution features, and the distribution of our target variable. Here we can see the correlation matrix of feature and target. This is the pollution trend over year, and this is our target average AQI by year. This is pollution trend by month and the AQI by month. Here we can see the histogram analysis of our feature distribution, and here you can see the relationship between feature and the AQI. Here, note that the AQI dataset is highly imbalanced with good air quality, with 95.96 percentage dominating, which makes accuracy along unreliable and requires metrics like F1 score and ROC accuracy for proper evaluation. Now move to machine learning model. First, I focus on regressor where the goal was predict the numerical AQI value. Model use linear regressor and random forest regressor. In linear regressor, we have achieved test R squared is equal to 0.83 and RMSE is 6.18. This model is fast and interpreter but limited in capturing non-linear relationship. Next is random forest regressor. Uh, we achieve we achieve R2 test R2 squared is 0.99 and RMSE is only 1.55. This significant improve occur because random forest capture non-linear interaction, handle large dataset effectively, and reduce variance using SML learning. Feature importance analysis uh, so that nitrogen dioxide mean along contribution nearly 87%, which aligns with domain knowledge. Next, I covered EQI value into health-based categories good, moderate, unhealthy, and sensitive group. This transformed the problem into multi-class classification tasks. A model use a logistic regressor and random forest classifier. A logistic regressor we achieve accuracy 96.6% and low macro F1 score due to class unbalanced, and random forest classifier accuracy is 99.8% and micro F1 score is 0.99. ROC curve is 0.999 and distribute a strong class imbalance. The random forest model perform unexpectedly well across all classes including minor classes. To ensure the result was not due to overfitting, I applied five-fold cross-validation hyperparameter tuning using randomized search CV. The cross-validation R squared score was a linear regressor 0.83 and random forest 0.97. The low standard deviation across folds confirmed that the model is sustainable and generalizable. The system can be applied in smart city pollution monitoring, early health risk warning system, and environment policy maker planning. AI assistant decision making platform with real time integration. This model can extend into live pollution forecasting system. Into the conclusion, machine learning are significantly enhanced pollution monitoring system. A random forest model provide highly effective for both regressor and classification. The project demonstrate how AI can support environmental sustainability. Thank you for watching.